Now that you know the basics of quadratics and also the vertex, we're going to talk about how to graph quadratic functions. We're going to start with quadratic equations and how to graph them, and then we're also going to add into that polynomial functions. So I want you to take a sheet of paper and I want you to fold it into fours. You're going to label one part the vertex, then you're going to have x-intercepts, y-intercepts, and then this is going to be where we actually end up putting the graph. You're going to have an assignment that you need to do that you'll take a picture of and send to me, so it's important that you really do practice this. The first one that we're going to look at is y equals 2x squared minus 8x plus 6. So our first job is to find the vertex. So we're going to do negative b over 2a. So in this case, the opposite of b is positive 8. Divided by 2, in this case a is also 2. So that gives us an x-coordinate of 2. Let's plug that back in. Plugging that back in gives us a y-coordinate of negative 2. So our vertex is at 2, negative 2. Let's go ahead and find the intercepts. So for an x-intercept, y is equal to 0. So we're going to set this equation equal to 0. You have two options then to solve this. You can either factor it or you could use the quadratic formula. I can see that a 2 can be factored out. So let's take the 2 out. So we have x squared minus 4x plus 3. And are there two numbers that multiply to 3 that add to negative 4? And there are. It's negative 1 and negative 3. So we're going to set each of these equal to 0. I've got x minus 1 equals 0. And x minus 3 equals 0. So in this case, x is equal to 1, and in this case, x is equal to 3. The next step is to find the y-intercepts. So for a y-intercept, it's the value of x that equals 0. That one's a little bit easier to solve because that's just simply plugging in 0 for x. So we plug in a 0, we plug in a 0, and so we end up with y is equal to 6. So our y-intercept is at 0, 6. So now we can go ahead and graph this. So it's important that I put all of the points that I've just found. I know that I've got the vertex at 2, negative 2, so I'm going to put that point on the graph. I know that I've got x-intercepts at x equals 1, and at x equals 3, and I also know that I've got a y-intercept up here at 6. I know that this graph is opening up because a is positive, so I'm going to put together these points, and that gives me enough to get the shape of the parabola. Let's look at another quadratic. Let's suppose we have f of x equals x squared plus 4x plus 4. The first step in graphing is to find the vertex. So because it's not in vertex form, we're going to do negative b over 2a, or negative 4 over 2 times 1, which gives us negative 2 as the x-coordinate. We need to take that and plug it back in. And when we plug that back in, you can now see that the y-coordinate of that vertex is 0. So our vertex is at negative 2, 0. Let's go ahead and find intercepts. So remember, we're going to set y equal to 0 for the x-intercept, and if it can be factored, we'll do that. And in this case, it can be. It's x plus 2, and x plus 2. So they have the same solution. In this case, x is equal to negative 2, which we already knew because that's the vertex. Now let's go ahead and find y-intercepts. So for a y-intercept, we're going to let x equal 0. So we've got 0 squared plus 4 times 0 plus 4, and that gives us 4. So let's plot what we know. We know that we've got our vertex is at negative 2, 0. I know that I've got this y-intercept at 0, 4, and that doesn't really appear to be enough. But if I use that axis of symmetry, I know that I've got another point that's also going to be 2 to the left of that point. That's going to give me enough then to make my parabola. Let's do one that's in vertex form. This makes finding the vertex a little bit easier, because I can look at that and see that the vertex is at 1, 3. Let's go ahead and jump to x-intercept. So we've got to let y equals 0. So when we do that, we can see that this may require a little bit more work. If we use the square root method and subtract 3 from both sides, we've got -3 equals the quantity x minus 1 squared. Well, I can't take the square root of both sides, so something must be strange with these x-intercepts. It doesn't look like there are any. Let's look at y-intercepts. For a y-intercept, we're going to let x be 0. So we've got -1 squared plus 3, which gives us 4. Let's put this on the graph and see what we can do. We know that the vertex is at 1, 3. We also know that it's opening up because there's an imaginary 1 sitting there. That should now explain why there aren't any x-intercepts, because the graph is opening up from 1, 3. We know that we've got a y-intercept at 0, 4. So over on this side, because of that axis of symmetry, there must also be a value at 4. Now we can go ahead and connect our points, and we have our parabola. Let's do one more that's in vertex form. So because this is in vertex form, we can see that this vertex is at 2, -3. Let's go ahead and find x-intercepts. So we're going to let y equals 0, and we're going to add 3 to both sides. So now we have 3 is equal to 2 times the quantity x minus 2 squared. Divide both sides by 2. And now we can take the square root of both sides. When we do that, that's a positive or a negative. We end up with positive or negative square root of 3/2 is equal to x minus 2, so add 2 to both sides. And this is going to end up being a decimal answer, and that'll happen sometimes on your test as well as sometimes in MyLabs Plus. When we do 2 plus the square root of 3/2, we get about 3.22. And when we do 2 minus the square root of 3/2, we're going to end up with about 0.775. And you will just approximate where those are located when you go to make your graph. Let's look at y-intercepts. We're going to let x equals 0. So 0 minus 2 squared minus 3, which is 2 times 4 minus 3, or 8 minus 3, which is going to give us 5. So let's go ahead and put these on the graph. So we know we've got the point 2, -3. We know that this graph is going to be opening up because A is positive. We've got those x-intercepts at about 3.22 and 0.775, and then we've got our y-intercept up here at 5. So we're going to connect all of them, and there's your parabola. Polynomial functions have the form f of x is equal to a times x to the n, where a is a constant. Let's look at how we graph these. The only way that I'm going to expect you to graph a polynomial function is using an xy table. So you're going to pick some values for x, plug them in, and determine the values of y that go with them. It is important to know what the shape of the graph should look like. So when n is odd, you're going to end up with these sort of squiggly looking graphs. Depending on whether A is positive or A is negative will determine whether it goes to the right or to the left. When n is even, you're going to end up with a U-shaped graph. And again, depending on whether A is positive or A is negative will determine whether that graph opens up or opens down. The total number of peaks and valleys on the graph of a polynomial function of a degree n is always going to be one less than the degree. And the number of x-intercepts on the graph of degree n is going to be at most n. So if it's x to the fourth, then the most number of x-intercepts that it can have is 4. In that case, the number of peaks and valleys would be 3. So let's look at one last example. If this is our polynomial function, the degree of this function is 3, so the number of peaks and valleys is 1 less than that. Maximum number of x-intercepts would also be 3. Here we have a degree of 5, so number of peaks and valleys would be 4, and the number of maximum x-intercepts would be 5. I'd like for you to practice with graphing.